Good morning, everyone. Looking back a few years ago, we would not be expected to be up here today talking about containers and how we utilize them across multiple data centers in the cloud. For one, a lot of this technology wasn't around at that time. But number two, we were currently using legacy systems and legacy processes in our technology. You have the clicker? I don't have a clicker. Oh, sorry. Thank you.
Is this it? Yeah. There we go.
Today we're going to walk you through a little bit of our journey as we led up towards containers, how we use containers, and then also some of our results that we've achieved. Up here is myself and Paul. You can see some of our contact information here up on GitHub if you want to reach out to us and learn a little bit more. But I'm going to start out by giving you a little bit of background on International Securities Exchange. We're no stranger to innovation, especially on the business side. We're the first all-electronic options exchange in the U.S. And additionally, we're the first U.S. securities exchange to go public. More recently, we merged with Eurex and became part of the global Deutsche Börse group. With that, it provided us an opportunity back in 2010, 2011, to launch a new global trading system that traded across multiple asset classes, provided us low latency, massive scale. But at the same time, there was also tremendous competition that was happening in our environment. It seemed like there's new exchanges propping up every month. At the time, I believe we're at 11 or 12, and today we're at 13 options exchanges. And how did each of the groups differentiate themselves was no longer just on market structure, but also on the pricing model, their technology capabilities, which included latency and throughput, and their business functionality. How quickly could they bring in new functionality that others wanted, specifically in the more complex type trading scenarios? For us, we knew we needed to do more than just have reliable and available systems that we had in our previous legacy environment. But we needed to utilize our new trading system to bring on business functionality faster into our operations and also try to reduce costs so we could be competitive in the pricing wars that had started to occur in our options business. We, of course, pulled together a bunch of executives and leading technology people and said, okay, what are the things that we're going to do? What are the projects that we can have? What are the technologies that we're going to use? And we laid out our vision and distributed that across our team, expecting everything to happen magically overnight, of course, which it doesn't. And one of the things that, when I look back to that time period and I think about what really helped us make that transition, it wasn't about the technologies you can expect. It was about the culture and the collaboration that we had within the groups. And this is where I give a great deal of credit to Paul here, who really started out with these stupid GitHub cups. And I don't even drink coffee, so I had a hard enough time with him walking around with these GitHub coffee cups. But what I didn't really realize at first was that he was being the person who is spearheading the collaboration at the ground level with our teams and asking them to join him up on GitHub to put all of our designs, our documentation, all the projects that we're working on, and share them across the multiple silos that we had built up in our technology group. With that allowed to really pull together our operations and engineering teams. And each time that someone collaborated up on our GitHub repository, he would actually go ahead and stop by their desk and tell them, thank you for contributing. Here's a coffee mug. And they'd walk around with that coffee mug and go get coffee and share their experiences of what they did in order to get their coffee mug. It started to build a great deal of trust between the groups and collaboration, and the results were amazing. Just from us using one standard way to collaborate as a team, we began to see things start to go through operations much more quickly. Here we had things that are coming out of our engineering teams that operations was ready to take on because they had seen it develop all the way through. So with that, we started to improve time to market. But the other great thing about leveraging this collaboration is now the teams were beginning to learn from one another. We added in training on scripting and coding to all the teams. And as we all learned how to code in these new technologies and leveraging our new system, we were able to rapidly advance in our automation capabilities. Our operations team was able to fully automate our daily run of our operation, all the configurations, how we built and distributed software, as well as all of our process failovers should we need them, and even our disaster recovery if required. From the engineering perspective, we were able to deliver the full stack automated, handing that off to operations, making them much more capable. In addition, we increased the transparency of what we were working on and allowed others to contribute to the projects that we were developing. As we start to look back at all of our teams beginning to actually code, I ran across this image, and I'm not sure exactly which magazine or what I ran into it, but it clearly just stated, yes, we code. And it was a big change for us as an organization who was used to looking at, in the operations area, red light, green light, and even in our engineering teams who had manually built systems in the past. And it really created a compounding effect for us as an organization. This is where it brought us to the point where we're beginning to leverage containers. And with that, I will turn it over to Paul Morgan.
Thank you. Morning. Rob has mentioned a little bit of our journey from a people perspective, and I'm going to go into a little bit of the technology. Traditionally, ISC has only had 2 data centers, one in New York, one in New Jersey. As Rob mentioned, originally everything was built by hand, and when I got there, I started working with the various teams to collaborate, build some transparency. Let's treat our infrastructure as code. And we started to become a victim of our own success at one point. A few years ago, we started to expand into AWS for testing purposes, and it became clear that 40 minutes to build a new host or expand infrastructure was just too slow. And I have to point out that we handle over 2 billion transactions during a typical market day. Our market data feeds consume up to 150 million messages per second. So we shard our infrastructure in a number of partitions. And we have to scale out these partitions in order to meet rising demands, to handle unexpected spikes in the market. And earlier this year, we decided that we were going to build a new physical data center in Chicago. And along this path, as we felt the pressure of the velocity we had developed, that we needed to find ways to turn over new infrastructure much more quickly, rebuild our infrastructure much more quickly. So in early 2013, when we learned about Docker, we were kind of excited, but at the same time, we were a little bit meh, because at that point, Docker would be just another layer on top of what we already managed. And we did not want to manage complexity. We wanted to get rid of the complexity. And then later that year, we found out about CoreOS. That was a turning point for us. We were so excited that we got the architecture team together, and thanks to Rob, we got funded for a mini project, and we immediately started playing with CoreOS, trying to learn, what does it mean to manage a read-only operating system? How does this work? And what we discovered pretty quickly is that we can treat CoreOS and Docker as invisible infrastructure. What previously would take 40 minutes to turn over, we can now turn over in less than 5 minutes. As you can imagine, we're pretty excited about GIFI and trusted computing. As a regulated financial service, we owe it to our members and to ourselves to have guarantees about the integrity of both our software and our hardware. And one of the cool things about CoreOS is the automated updates. Previously, we would spend up to 70% of our time just managing the patches and the operating system updates. With CoreOS, we let the updates come through automatically. We free up all our time to focus on revenue-generating projects, focus on our trading platform. In order to scale out to 150 million messages per second, over 2 billion transactions per day across a lot of partitions, we have to use multicast. So one of the key drivers for us to be able to deploy CoreOS and Docker and our trading platform in cloud environments is a technology from Weaveworks. Weave allows us to use multicast in the cloud as an overlay network. We looked at every overlay network available, and Weave is really the only one that allows us to treat multicast as invisible infrastructure. One of the other things that we needed to develop was a ISE multicast proxy. This allows us to take our data feeds where we subscribe in Chicago and New Jersey and transmit these 150 million messages per second to all of our other data centers. On the Windows side, we use Packer and Terraform to provide operations with self-service infrastructure. Our ops team builds their own hosts now. It takes about 2 minutes in AWS, and it takes about 10 minutes on bare metal, mainly due to the power on self-test of the hardware. And we also discovered that authentication needed to change when dealing with immutable read-only infrastructure. So we have set up boundaries where we use two-factor authentication. And previously, when we were on Red Hat, we would use Active Directory integration with our hosts. That is gone now. We use database-driven authentication, two-factor auth for every boundary. As an example of containerized infrastructure at ISE, we still use Puppet, but we've containerized our Puppet infrastructure. And what we show up here is that we have Puppet database running in a container. We've got a dashboard that's read-only running in a container. We've got our Puppet master. And in order to meet the demands of our test teams, running hundreds, in some cases thousands of regression tests every day through our continuous delivery process, we built a build, deploy, and test system. It runs on CoreOS, it runs in containers, and GitHub is too slow for us at this point for the test harness. We put all of our configuration, static configuration data into GitHub, and we deploy it through Puppet to our long-lived infrastructure. But for our short-lived infrastructure, our BDT system pumps dynamic configuration data into our etcd cluster, and then we use that to run what we call host enforce. We've also decided that every host that needs write access to our etcd cluster or read access to our etcd cluster runs an etcd proxy. It's a simple architecture. We're able to tell the developers and operations and sysadmins, how do you talk to etcd? Localhost, period. Makes it easy for them. This chart there's a lot going on in this chart, but I've tried to make it easy. It shows that we have On the right-hand side, we're graphing throughput. On the left-hand vertical axis, we've got our latency. The green ramp-up test shows our throughput. And it shows that on CoreOS, we can get around 50,000 transactions per second in a partition, maintaining sub-200 microsecond latency. This chart is kind of exciting because it looks exactly the same as all of our performance tests with the Red Hat real-time kernel. And it turns out that CoreOS, using the upstream stock kernel, has almost all of the real-time patches already merged. So we get great performance, great latency profiles. We use these tests to determine how many partitions we need to handle the 2 billion transactions a day. In production, we typically run a host at an average of 20,000 transactions per second and just scale out horizontally. Multicast allows us to scale out horizontally without any performance loss. So where do we stand today? I'll let Rob describe.
You can give me the clicker back.
Give you the clicker back.
All right. So I think we walked through most of the aspects of kind of our journey so far. But over the last few years, this has been a tremendous change, just a transformation for our IT organization, moving from legacy technologies into this new environment. You know, we weren't one of the startups that started out with a clean slate. We had a number of technologies that we had to convert over and begin to utilize. But our operations team is now able to use a fully automated configuration and orchestration. What we found with that is it just freed up a tremendous amount of cycles for them. When they're sitting down in the operations room today, they're no longer sitting there looking at red light, green light, and watching for the next event. They're coding. They're focusing on what is the next thing that I can do to contribute to the success of our company. That might be improving our operations, or it may even be helping us with the build, deploy, and test pipeline, which our operations team played a significant factor in building out that configuration. It was the true integration of our silos of automation across our build packaging, our testing, and our automated deployment that we've went through today. With this, we're able to be much more rapid in our delivery of business functionality into the operations and help with our business in delivering that to our customers. In addition, now we're able to run our workloads across any infrastructure. Any one of our data centers, whatever ends up being the decision for us, what might be less costly or just more agile for us to bring up a new test environment and try out some new business functionality that our customers may want. In addition, we were able to help start to compete at the pricing level. We launched 2 new markets. One of them, I should say, we've already launched called ISE Gemini, and we're about to launch ISE Mercury in early of this next year. In addition, over that same time period, we reduced IT spend by more than 25%. So we've seen significant improvements in that area as well. With that, we're just going to ask if any of you guys have any questions about what we presented, or otherwise you're more than welcome to reach us via GitHub or anytime after in the conference.
Did you separate your IT spend for people time, hardware? Any idea what the split was, 25% of some of that, or just people time?
No, it was the sum of that. So it really factored into changes that we made partially from hardware moving over there, software moving to open source software that we're leveraging, as well as people and becoming more efficient.
And just what were you comparing against? Was that Red Hat real time?
Well, we initially started out, we were using OpenVMS is what we were running in our environment prior to moving to a Linux operating system.
6 years ago.
6 years ago, yep.
So we switched from VMS to Red Hat, and now we're dropping CoreOS in place.
And 25% is from VMS?
No, I'm sorry, my apologies. That was from 2011, and so at that time we were running Linux at that time.
And I should point out that this overall cost reduction has not come from headcount. It's come from the simplified operation of our infrastructure so that the existing people can do more.
The ratio of servers to people on your team.
That's a good question. I don't know that one right offhand.
For Linux engineering, we have 2 engineers and roughly 600 long-lived boxes and however many short-lived boxes stand up and go down every day.
On the Windows side, we have we have 3 engineers.
3 Windows engineers and about 500 Windows boxes for long-lived.
Right.
Yes.
Yeah, sure.
One second, we're having trouble with math. So you've got 3 data centers and 600 servers?
No, we have about 1,100 servers, long-lived.
So you got a couple cages?
No, we have separate data centers within hosted facilities. That's correct, with multiple cages in each. Mm-hmm.
We had images of concrete and drugs.
Oh,
Understood.
Can you put numbers on, kind of the revenue that you've been able to capture? Because now instead of managing your infrastructure, your people are free to develop new things that might capture revenue or further make your infrastructure even more efficient than it already was.
So we're a private company, so we don't really share a lot of our revenue numbers, unfortunately. So I can't share that with you. But in the competitive environment that we're in right now, probably our biggest measurement from the business was related to us being able to provide pricing decreases, able to be more efficient and competitive in the ever decreasing pricing wars and competition between the exchanges. So there is actually a number that we hit, but I'm not sure that I'm available to share it, and the number of pennies per contract that we were able to
and I should also point out that it's freed us up to do all kinds of interesting side projects. Was there another question?
Yeah, how much of your CoreOS is deployed in Amazon versus your 5 data centers?
On the Linux side, everything in AWS is CoreOS. On the physical data centers, probably 20% right now is CoreOS and growing.
Yeah, and we really look at that number as growing significantly over this next year. So, we did some of these benchmarks really to see whether or not our production trading systems could leverage this infrastructure. And so this was highly successful for us, and we look forward to using it more in our other environments.
For example, our Chicago data center is 100% CoreOS. Can you say again louder? It's under consideration.
Go ahead.
Can you speak to your switching topology, software-defined networking, besides we, so actual switches themselves? It's just Arista?
We have,
I'm sorry. He was asking us about our network infrastructure and what we run in our environment. And we do have a mixture in our environment. So we have some Arista, we have Cisco, we have Juniper throughout the environment.
on the bare metal, it's obviously important for us to have the absolute lowest latency, so we look for switches that have the highest cut-through rates.
So, but you're also paying a recap.
Say again?
You're also paying for encapsulation, decapsulation through G, so.
For our
That's correct.
production performance, we don't use Weave on bare metal.
Yes.
We run our containers with the network namespace disabled.
Absolutely.
We have to stay under 200 microseconds. We're even trying to find faster switches today. And we also use InfiniBand with verbs because Ethernet costs us about 100 mics.
Now you're sounding like finance guys. You weren't before.
Paul, quick question. You mentioned, I think one of the numbers you said is 40 minutes to spin up a VM versus 5 minutes to spin up a container.
No,
That's
40 minutes to spin up bare metal.
Oh, bare metal system. Okay. So I guess my question is going in the direction, what are the bigger benefits you see of containers over quote unquote traditional virtualization? And coming back to another slide where you mentioned you regard your current stack as being invisible infrastructure, which sounds incredibly compelling, but could you give a bit more detail as to what you mean by invisible and how that differs from, say, just running a bunch of VMs?
It's the management overhead. With a traditional platform, we have thousands of packages to manage. With CoreOS, there's none. It's a monolithic OS. We're able to do all the system tunables that we need through systemd unit files. And I like to call it time shifting. We pre-build everything. The CoreOS host, the operating system is pre-built. It's a matter of pixie booting into the machine and then pulling down an image that's already been built, instantiating it, you're done. All testing of the containers happens automatically. Every time our development team releases a new version of our trading platform, it gets triggered through Jenkins to our build, deploy, and test pipeline. And eventually, a version of the container is available that we think is production ready.
I wanted to know a bit more about the culture change that occurred. I'm over here if you're looking.
Oh,
yeah.
Thank you.
So it sounds like you did quite a drastic change in the way you produce your code internally, but also I was curious if you could say, what has that done to the culture of your engineering teams, and how has it affected the way in which you hire? Are there different skill sets you're now looking for that you weren't previously? Do you care more about collaborative spirit versus individual contribution?
Mm-hmm.
All of the above.
Yeah.
It sounds like a cop-out answer, but it's really true. We obviously, when we're hiring, we look for the best talent, but we also need people who we like to work with. We need to be able to go hang out, have a beer. We need to be able to speak candidly with each other and say, I see what you're doing here, but something about your code smells. And have that conversation without getting our feelings hurt. It's an open source paradigm. We're like a mini open source inside of our financial exchange.
And even from our operations side, where the hiring that we have there, we're hiring people who have their computer science degree or computer engineering degrees. Whereas in the past, we looked for somebody who had maybe a more general type of technology degree who was just interested in starting up in that environment. Now we're looking for the most talented people that we can bring in to fill any of our positions that we have within the group, and continue to raise the bar is really what we're hoping to. Trying to find somebody who has a new set of experiences that can add to what we have already. So sometimes somebody will challenge us a little bit with something new or a different way of thinking.
And what's really been curious over the last 2 years especially is that operators have learned to code, moved into development, or moved into other companies, some of the startups like Shutterstock and so forth. So, we're starting to become this churn of training people up. Some of them get positions within our company that they never would have gotten in any other experience. I'm kind of proud of that.
So it's the knockout question, just before the coffee. I'm very fond of CoreOS. We use it in production as well. But when I look at your profile, and also probably my profile in the near future, is that we have a big dependency on CoreOS. And we also have the stable channel we connect to. What are your ideas about your dependency on CoreOS? like hypothetically, maybe they stop, or maybe they charge you in a different way, or maybe you built a lot of on this good thing of CoreOS, and I'm very fond of it. But this is a question that keeps going through my mind as well, and it's partly why I'm here these 2 days.
What is the question?
Your dependency on CoreOS.
Dependency on CoreOS.
So you have 600 machines on CoreOS. When the stable channel stops, or when the CoreOS initiative stops, how do you think of that?
Yeah, I think today we're not all on CoreOS. I think we also need to understand a little bit more about the pricing model wherever Alex is. But with that, I think it's important for us to always have options and be continuing to look at other operating systems that are available. Even if we move the majority of our systems to CoreOS, I think we'll always have something in the background that we're working on as our next operating system, or have that availability. So I don't know if I have any other comments on that. Do you anything else about our reliance on CoreOS?
Maybe they'll go back to the
Yeah. Been there, done that. Hey.
No thanks.
No, thank you.
Now we like the distributed model.
Yes.
How unique are you in your industry with regard to CoreOS? Are you seeing peers
Ooh.
copy your template?
I don't know if I'd say copy. I think each company's been on their own journey towards that. A number of us in the financial services community, if you looked at the number of us who were running OpenVMS 6 years ago, it was still a fairly large number, unfortunately. And the transition that we made to Linux, we saw a lot of the other financial services companies do that as well. So I think it's just kind of an evolution for us. In general, we're comfortable being, I don't want to even say leading edge, but near that leading edge. We're definitely not comfortable being bleeding edge a lot of times with the new technologies. Where we feel more comfortable right now in that area is about leveraging the different processes that we can handle internally. The containers allows us a great ability to move workloads around. That's something that we feel like we can really stretch and be out there without compromising anything to our environment.
To use the traditional analogy of a bus traveling down the highway at 60 miles an hour, we're changing out the wheels and the frame and the engine and everything. So it's a process. We're not done with our journey. Yes? Today we orchestrate our container placement using Puppet, primarily because it's declarative and allows us to have absolute certainty of where things are running, which is important in a sub 200 microsecond environment. We hope to use Kubernetes to place containers in the future. Yes?
Do you care where your containers get placed at the smaller than a data center level? Or it just has to be in one specific data center?
We do. We have to have containers that are grouped into partitions.
Mm-hmm.
So we have absolute knowledge of what's in a partition. Now, as far as where those partitions are, we don't care, because every partition is on an IB network and subscribes to the multicast feeds. So within a partition, yes. Outside the partition, not so much.
Excellent. Well, thank you very, very much, gentlemen. I think that for a lot of these people,
Think about it.